Hello. We're going to do a little more work with fractions today, and I think I might ought to tell you this video may take a little bit longer because what we have to cover to get a full picture of it and understand it. I didn't want to split it into two because it works better if you can see how it all fits together. So you may want to wait to watch this until you're sure you have enough time to get all the way through it so you can see the whole thing all together. So let's just quick review what a fraction is so we know what we're working with. If I have that fraction 5/9, remember the denominator tells me what I'm working with. In this case, I'm working with ninths. And remember, you have to understand and remember that the number tells you a little bit about it. When I say ninths, I have to envision some whole thing split into 9 equal parts. So the denominator tells me what I'm dealing with. The numerator tells me how many that I have. And so what I have here is 5 of these things that I call ninths. You need to be clear on that, and if you are, it will make what we're going to be talking about today, adding and subtracting fractions, a whole lot simpler. And part of it's going to be really easy. First of all, we want to talk about adding fractions when the denominators are the same. So if I have 5/9 plus 2/9, then what I need to think of, because be sure you remember, when you're adding, we can only add things that are alike. If you add 5 apples and 4 oranges, the best you can do is 5 apples and 4 oranges. Saying 9 pieces of fruit wouldn't help. So whenever we have a problem, first thing we want to check to see what we're doing here. So we're seeing that we're adding here. That means we got to make sure we have things that are alike so that we can add them. But where do we look? We look at the denominator to tell what we're adding here. And in this case, we're adding ninths in each case. So this is something we can add. Now, a couple of things you want to remember. If you add apples and apples, what are you going to get? Okay, apples. You always get whatever it is you're adding. So if I add ninths and ninths, what am I going to get? All right, so over here, I'll write my denominator down as ninths. I'm going to get ninths if I add ninths. Now remember, the numerator tells me how many of them I have. So I have 5 here, 2 here. Altogether, how many ninths am I going to have? Okay, 7. So we put the 7 over there because the 7 is supposed to tell us how many of them we have. So you can see, I hope you can see, if you understand that the denominator tells you what you're dealing with and the numerator tells you how many, then it's fairly simple to add fractions when the denominators are the same. So we have something like this, 1/5 plus 3/5. We look at this, we ask ourselves, okay, what are we adding here? We're adding fifths. What are we going to get then? We're going to get fifths. And that means we write our 5 in the denominator. And it's probably a good idea to do that. Just a word of caution. When you think about adding, the natural tendency of the brain is to think, okay, I'm adding these two together, so I got to get 18. So that's why you've got to think carefully about you get what you're adding. If I'm adding fifths, I'm going to get fifths. Then I ask myself, how many of them? How many here? Okay, 1. How many here? 3. Altogether then, we have 4 of them. See, pretty simple, straightforward way to do that if you just remember that. Now, let's try one more. I have 1/8 plus 3/8. Okay, what am I adding here? 8ths, that's what I'm going to get. How many of them? How many here? 1. Here? 3. Altogether? 4. Okay, now, don't forget, you got to remember all these little details because otherwise you get in trouble. Is this the answer that we're looking for? Okay, as far as we went, yes. But the problem is, we always have to check to see if our answer is what it can be. So when I look at that 4/8, the last question I always have to ask myself when I'm talking about fractions, can I reduce it? So, how do we reduce fractions? Okay, look for a common factor, because we get to take out any common factor in the numerator and denominator. And when we look at that, what can you see? Okay, now if you can see it, fine, just go ahead and do it. If not, you can always rewrite that so that you can see what that common factor is. Or you could carry those down further, make this one 2 times 2, this would be 2 times 2 times 2. Of course, to save time, you want to get to the point where you can do that and you're comfortable enough with numbers that you can look at it and tell what it is just from that. Okay, now that's the easy part. And this part that we're going to deal with now is the part that's a little more challenging and is the part that's going to require a little more work. And that is, what do we do when we add things that don't have a common denominator? So if I have 3/7 plus 4/5. Now I ask myself the same questions. What am I doing in this problem? I'm adding fractions. What do I have to have in order to be able to add fractions? Same denominator. So I look at this and I say, oops, that's not the same denominator. Can I add those? Well, based on what we said, you wouldn't be able to. So we've got to find some way to deal with this, because surely they wouldn't ask us to add fractions if it were impossible. There must be some way for us to do this. Fortunately for us, one of these mathematician people, the kind that are curious and think, what if, probably thought something like this. You know what? If those two things had something in common, so I could describe each one of them in terms of that common thing, then I'd be okay. In other words, I make them into something that's the same. And so that's what we're going to talk about now. And this is the part that's going to take a little bit longer. How do we do that? Now, a lot of times when we have some new idea that we have to get, it's helpful if we can get a visualization of what's happening. So let's take these two fractions and do that visualization. And then we'll figure out how to do it without having to go to all the work. So, if I have my 3/7, remember, I have 7 equal parts, and I'm dealing with 3 of those. So right there, the parts that I've checked represent the 3/7. Okay, now I've got this 4/5. I want to make this, or find out something that these two have in common. So what I'm going to do is I'm going to use the same figure to draw my 4/5. But if I draw columns the same way that I did there, there's no way in the world I'm going to be able to tell that. I'm not going to be able to distinguish between them. So what I'll do, and this is all right, no question, no problem, I'm going to draw my 4/5, only I'm going to draw them horizontally. So I have okay, remember the rule is that you use your imagination because I'm not a terrific drawer, but now I have 4/5. And so my 4/5 are these 4 rows. Okay, the first thing we need to know, if you look at that, you can see those little square things we have here. Those little square things are part of the rows and the columns. So that is something that's common to both of these fractions, whatever it is. Well, the next thing we have to ask ourselves is, okay, what do we call them? We got to have some name for them. And that's when we think about what we know. The name of a fraction comes from how many make up a whole, W-H-O-L-E. Remember, these 7ths were because there were 7 in the whole. These 5ths were because there were 4, 7 columns and 4 rows. So we have to find out how many of these we have. Well, one of the things I can do is I can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That's bad enough with 7ths and 5ths. What would we do if we were talking about 16ths and 33rds? How many of you'd like to draw that picture and count those squares? So is there something else we can do? Well, think about it. We have 7 rows, and we have 7 columns, and because we have 5 rows, each one of these columns has 5 of those little squares in it. So I have 7 groups of 5. Well, what does your brain tell you when you think 7 groups of 5? Doesn't it tell you to multiply those together? And when you do that, you will get exactly what we got when we counted. So we know our fractions, the common part that they're going to have is going to be 35ths, the names of those little squares. Okay, now let's look at how many squares there are in this 3/7. In the 3/7, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 of them. Okay, in the 4/5 there are, and let's do it the way we did the other because that was a little bit quicker. We have 4 rows, and each one of those rows have 7 squares in them. So we've got 4 groups of 7, which gives us the 25. Oops. I said 25 and my brain went back and thought about the 4 times 7 I've just talked about. Well, that's what it is. What am I doing? I'm right. My brain knew what I was doing. I didn't. Okay, so let's go on. Now we look at it and say, okay, can we add these? Sure. Now they're 35ths. What are we going to get when we add these fractions in this form? Well, we're adding 35ths, so we're going to get 35ths. How many of them do we have? We've got 15 here, and we've got 28 here, so altogether that's, okay, let's add 10 of those to the 28, because we can do that in our head. There's 38, and we've got 5 left over. We'll take 2 of those to make it to 40. That leaves us 3, so we've got 43 35ths. If you didn't catch what I just did there, go ahead and write it down on a piece of paper. I always like to try and help my students see that if they learn to do things with easy numbers, they can actually do it in their head. So that's why I did that. But that would be our answer. So in fact, we can add fractions that have different denominators. We just have to do what we have to do to make sure that we change the denominators so they're the same. Now, we don't want to have to draw a picture every time, because like I said, you get big fractions with big numbers, big denominators, that could be a whole lot of work and a big mess. So we don't want to have to do that. So we want to see if there is some way we can change these fractions to their equivalent ones. Now, in case you're wondering, we use the word equivalent because if you're like me, my brain looks at this and says, no, they're not the same. They're not the same. But my brain will accept the fact that they're equivalent. They have the same value, they just don't look the same. So we'll use the word equivalent equations to help us deal with that. So we want to see how we can find out what that is. Okay, you know what we did here, don't you, to get the 35? We just multiplied the denominators together, and so that's one of the things we can do. Let's just erase our picture here so we can start over with these numbers, and we'll go through the process of finding that common denominator that we need. Basically, we had 7 rows, or 7 columns and 5 rows, so we had 7 groups of 5. So one of the things you can do is just multiply those denominators together. So that gave us the 35. All right, so let's see then how we can find out what the number is without having to draw the picture and count. Well, this is what I want my fraction to look like. This is what it currently looks like. So I'm asking myself, what do I need to do to make it look like what it needs to look like? That's my only question. So I look at this, and one of the things we can do, we can use what we just said. I multiplied the 7 times the 5 to get the 35. So if that's what I have to do to change that 7 to a 35, why don't I do it? So I multiply 7 times 5, and sure enough, that gives me the 35. But remember, we don't want to change our fraction. We don't want to change its value. We just want to change the way it looks. Now, there is a number that we can multiply things by that doesn't change the value. Does anybody know remember what that number is? Okay, 1. 1 times anything is just that same number. Now, it doesn't actually have to be a 1. Any number divided by itself, if you remember, 13 divided by 13 is 1. So I can multiply by a form of 1. I don't have to multiply the 1. Now, I know I do have to have a 5 to multiply the 7, because it has to be 35. Well then, if I have to have that 5 in the denominator, then I'm going to make it into a 1 by multiplying the 5 in the numerator as well. So I've got 7 times 5 gives me the 35. I got 3 times 5 gives me the 15. And if you look back at the video, you'll see that that's exactly what we got when we counted. Over here, I asked myself, what do I need to multiply that 5 by in order to turn it into the 35 it has to be? Okay, times the 7. But if I multiply the denominator by a 7, what do I have to multiply the numerator by? Okay, also a 7. So my numerator for this fraction now is going to be 7 times 4, or 28. Does that look familiar? That's exactly what we got before. Now, it's important to understand there's something we have to deal with. We have a problem, and that's all we're doing. We're dealing with what we have to deal with to be able to do what we need to do. And once you get that point in math where you understand, I got a problem, I got to deal with it. So I find a way to deal with it, I do it. I just have to be able to deal with the problem that I have to get where I need to be. And so that's all we're talking about here. So we've just found a way that we can get where we need to be. Now, there's some other things we can do besides multiplying the numerator and denominator, because sometimes you get really, really, really big numbers if you just multiply the numerator and denominator. So we want to look at some other options. So in those cases, we can get the result we need without having to go to all that work. Now, for example, this one, the 35, came from 7 and 5. There isn't much else we can do because 7 and 5 are each prime numbers. So the smallest number that those two numbers will divide into is the number you get when you multiply them together. But let's say we have something like this. 3 over 40 plus 5 over 80. Do you really want to multiply 40 times 80 to get your denominator and have to deal with a denominator that is 3,200? Well, let's explore this idea of the smallest number that they'll both divide into, because 35 is the smallest number that 7 and 5 will each divide into. So is there a number here that you can see that both of them would divide into, not something that will divide into them, but they will both divide into, that we could work with, that might make this a little easier? Well, I picked these numbers easy so you could get the idea. So then once we see that it works, then we can use it however we have to. Can you see that 40 will go into 80? Okay, and 80 will certainly go into 80. So in this case, the smallest number that both of these will divide into is an 80. So instead of having to work with 3,200, which is what we're going to have to do if we multiply those two, we can deal with our fractions having to be 80. Okay, so now we look at where we are and see what we have to do. I don't want that 40 there, it's got to be an 80. So what do I have to multiply 40 by in order to have it end up 80? Okay, that's pretty simple. We multiply by 2. But because I have to multiply by a form of 1, if I multiply the denominator by 2, what do I have to do? Okay, multiply the numerator by 2. So now my numerator is going to be 3 times 2, or 6. Okay, what about this one over here? Well, it's already 80. For heaven's sakes, if it ain't broke, don't fix it. I mean, you don't have to do anything to it. It's already the way it needs to be, so just rewrite it down there. Now you see, I can add these together because the denominators are the same. If I add 80th and 80th, what am I going to get? I'm going to get 80th. How many of them am I going to have? Got 6 here, 5 here. Altogether, that is 11 of them. Check it out. 11's a prime number. Certainly doesn't go into 80. So I don't have to worry about reducing it, and that is my answer. So we can either multiply the numerators together, or we can find the smallest number that each one of them will divide into. Now, sometimes these two don't work because it's the numbers we have to multiply together would be too big, and the 80 it works, but I mean, we don't want to multiply the 80 times the 40. We can find it, and of course, you know what? If you can look at it and tell what that smallest number is, go for it. These other things we're going to talk about are just options when the ones that we think are possible don't really work very well for us. So be sure and keep that in mind. You don't have to do that. So let's take an example that would present a different kind of problem to us, and see what we would do. Let's say we have something like this. 5/12 plus 9/14. 12 times 14 is 168. That's a pretty big number to have to deal with. So if we don't have to deal with it, I would think we'd want to find something else. I don't know about you, but I can't just look at that and tell what number they would both go into. So I'm going to come up with something and see if this may not, let's see if we can find something else that will help us in a situation like this and not be quite so much work. Okay, 6, any number at all that you want to pick. That number, I said 6, so let's use that as an example. 6 will go into 6, 12, 18, 24, 30, 36, 30, 42, and so on. Those are the only numbers that 6 will divide into. In other words, 6 will only divide into numbers that have 6 as a factor. Okay, is everybody clear on that? You'd have to have 6 as a factor. You won't have 6 as a factor unless you have the factors of 6 in it. So I'm going to need to have a 3 and a 2. 3 times 2 is 6, so 3 and 2 are factors of 6. I need to have the factors 3 and 2 in my number, whatever it's going to be, or else 6 won't divide into it. Same thing is going to be true here. In order for 12 to go into this number we need, it's going to have the factors of 12 in it. 14, we're going to have the factors of 14. So what we're going to do now is we're going to find the factors of 12 and 14. Then we're going to make sure we include every one of those factors, but we're just going to do it once because we don't want any bigger number than we need to. I mean, like I said, we could multiply 12 times 14, but that's an awfully big number. We'd rather not have to work with it. So we take the factors. 12, no matter how you go, let's say you do 6 times 2, and then go on with 6, and you get 3 times 2. 12 will not divide into any number that doesn't have a factor of 3 and 2 factors of 2. Okay, over here for 14, we get 7 and 2. 7's a prime and so is 2, so those are the only. 14 will not go into any number that doesn't have a factor of 7 and a factor of 2. Okay, now remember what we said we were looking for, because this is kind of key to helping you remember this. We're looking for the smallest number that both 12 and 14 will divide into. Okay, so they came up with a name for that. To represent the idea of smallest, they used the idea of least. It has to be something for both of them because they both have to go into it, so we use the word common. And any number, like the example I used with 6, any number will divide into any of its multiples because you get the multiples by multiplying the number by 1, 2, 3, 4, 5, 6, 7, 8. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3. So 6 is a factor of every one of those. So we put multiple. We use this idea of least common multiple rather than just common denominator because hopefully it will help us remember how we find it. And they abbreviate it. So they call it the LCM, or the least common multiple. So when I look for this least common multiple, which is going to become my common denominator, I have to have a factor of 3 and 2 factors of 2. They have to be there or 12 will not go into this number. So I include them. Now I come over and look at 14. We need a factor of 7 and a factor of 2 to have a 14. Well, we've got plenty of 2's. We only need 1, we got 2, but we don't have a 7. So we're going to include that. When I multiply these numbers together, I'm going to know what my least common multiple is. 3 times 2 is 6, times 2 is 12, times 7 is 84. And that's what my denominator is going to be. This will work every time regardless of what the denominators are. So if you want one way that you can always use that will always work, this is it. And if you can look at them and tell what the least common multiple is or the common denominator is, go for it. But this will always work if you want one way that will always work. Okay, so now we just got to convert our fractions here into, remember the word we use, equivalent fractions. The nice thing about this method is you can actually look at where we start. Here's the 12. Here's what we had to have the denominator we needed. And you can look and compare this. And you can tell the one you're missing. And that's the one you're going to have to multiply the numerator and denominator by. So we multiply the numerator and denominator by 7. So our numerator now is going to be 35. So 5 12ths is the same thing as 35 84ths. Okay, for the 14, here's the 14. We'll use a different symbol. What are we missing? Well, you can look at it and see. We're missing 3 times 2, or 6. So we multiply the numerator and denominator of our fraction by 6. And we get 9 times 6 is 54. So now they have the same denominator. We can add them. Our denominator is going to be 84 because we're adding 84ths. When you add apples and apples, you get apples. If you add 84ths and 84ths, you're going to get 84ths. I have 35 of them here, 54 of them there. And if you want to add the 30 and the 54, that's pretty easy to do in your head. That's 84 plus 5 more is 89. 89 84ths is our answer. Okay, now one last thing before we call this one an end. What do you think would be the difference in what we do if we're talking about subtracting fractions instead of adding them? What would be different? Well, let's take an example. 9/13 minus 2/3. What's going to be the difference? Well, we're still adding and subtracting. We still have to have the same thing. If we don't have it, we have to make it. Now in this case, these two are prime, so our denominator has to be the product of those two. I mean, you can talk about finding factors and all, but it's still going to be that. So we've got our least common multiple is going to be 3 times 13, or 39. Okay, let's write this down here so we've got it. So that's what our denominator is going to be here. To change 13 to 39, we need a 3. That we didn't have, so we have to multiply the numerator and denominator by 3. 9 times 3 gives us 27. Over here, we have to multiply by the 13. And there you can tell, it's right there. We got 3 times 13, so there's our 3. We need a 13, numerator and denominator. 2 times 13 is 26. Now, what's the difference with what we have left? Well, I'm subtracting 39ths, so I'm going to get 39ths. whether you're adding or subtracting either one, you're going to get whatever you're adding or subtracting. Then the question you ask yourself is how many? And here's where the difference comes in. I've got 27 and I'm subtracting 26. We can handle that one, right? 27 minus 26, I'm going to have 1 left over. So everything you've learned about adding works exactly, this follows the same pattern when you're subtracting. The only difference is now you're subtracting instead of you're adding. So that's the only thing you have to remember. You just have to remember that you subtract. When you're subtracting fractions, you subtract the numerators. So you get the common denominator, and then you do subtracting. Okay? Spend some time with this. Once you get the idea, it's really fairly simple, but spend some time, think about it, review the notes and the video until you're comfortable with how this works, and then good luck to you. I hope it works for you. It's an easy idea once you get used to it. And thanks again for coming. We'll see you later. Bye.